Hi, my name is Sandhya Rani, lecturer in mathematics. So, today we are going to topic differentiation equations of first order and first degree. So, what is the differential equation? So, differential equation of first order and first degree. Only first order conditions ni page cheskoni. So, discussions today topic differential equation. First of all, differential equation. What is the differential equation? An equation involving dependent and independent variables and the derivative of one or more dependent variables with respect to of conditions. So, one or more dependent variables with respect to one or more independent variables is called a differential equation. What is the differential equation? An equation involving the independent variables and dependent variables. So, how many dependent variables independence involving the these differential equations? So, one or more dependent variables and one or more independent variables is called a differential equation. So, for example, x plus y into dy by dx is equal to 0. And so, one or more examples, d square y by dx square plus 2x into dy by dx plus 2y is equal to 0. So, taken off third example, k into d square y by dx square is equal to 1 plus dy by dx whole square. So, whole power of 3 by 2. So, the 5 conditions. So, given of examples of conditions. And next, so differential equation. Differential equations. Two types of differential equation. What is the two types of differential equations? Ordinary differential equations, partially differential equations. So, ordinary differential equation, partially differential equation. What is the ordinary differential? What is the partially differential equation? So, first of all, ordinary differential. So, explain the ordinary differential equation. So, ordinary differential equation, so definition of the, so which involving only one independent variable is known as ordinary differential equation. So what is the ordinary differential equation? An equation and differential equation which involved only one independent variable. Only one independent variable is known as an ordinary differential equation. So, for example, x plus y into dy by dx is equal to 0. Of course, second order conditions, d square y by dx square plus 2x into dy by dx plus 2y is equal to 0. So, one or more. So, for example, and next, ordinary differential equations. What is the ordinary differential equations? Only one independent variables. Okay. So next, differential equations ki independent variables or one or more dependent variables involving that equation. So is called a ordinary differential. But ordinary differential is two types of ordinary differential. So two types of differential equations. How many differential equations? Two types. So, one ordinary differential equation, second partially differential equation. So, ordinary differential equations definition, so only one independent variable so involved in these differential equations. So, it's called a ordinary differential equations. So, next, partially differential equation. Partially differential equation. So, the differential equation which involving two or more independent variables. Ordinary differential equations one independent variables involved in this differential equation. So, partially differential equation. Partially differential equation. Only two involving the two or more independent variables. Two independent variables or one or more independent variables involving the this differential equations is called a partially differential equation. So for example, dou square v by dou x square plus dou square v square by dou y square plus dou square v by dou z square is equal to 0. So with respect to one or more independent variables. Okay. So partially differential equations ki. So a differential equation which involves two or more independent variables and partially derivatives with respect to them is known as a partially differential equation. One or more independent variables so involved in the partially differentiation. Okay. So next, ordinary differential equations. Ordinary differential equations ki. So degree of differential equations. So order of differential equations ni two types of conditions ni base cheskoni. So the ordinary of the higher order derivatives involving the differential equation is called the order of differential equation. Next topic, order of differential equation, degree of differential equation. Order of differential equation, what is the order of differential equation? The order of the highest order derivatives involved in a differential equation is called the order of differential equation. And next, degree of differential equation. What is the degree of differential equation? The degree of differential equation is the degree of the highest order derivative present in the equation after the differential equation has been more free from the radicals and fractions and for as the derivatives are concerned. So v plus m into dr by dm అనే కండిషన్స్ ని బేస్ చేసుకొని ఉన్నాయి. ఫర్ ఎగ్జాంపుల్, సో v d square y by dx square whole power 3 plus 2x into dy by dx plus 3y is equal to 0. So order is also 2 and degree is also whole power 3. So degree means 3 condition వచ్చేస్తుంది. So order 2, degree 3. So this is also degree of differential equation of conditions. So one or more examples, k into d square y by dx square is equal to 1 plus dy by dx square whole power 3 by 2. So this is also, so y order, this is also equations. So taken a order is equal to 2, degree is equal to 1. Okay. So next, this is also degree of differential equations. So degree of differential equations and next order of differential equations and degree of differential each. So given of equation, so how to find the order and degree? So order, ordinary differential equation. So next again topic, ordinary differential equation. So ordinary differential equation, so an ordinary differential equation of first order and first degree is of the form dy by dx plus f of x comma y is equal to 0, which is a sometimes conversely written as, so conventionally written as mdx plus ndy is equal to 0, this equation 2. So So what is the ordinary differential equation? What is the ordinary differential equation? Is of the form mdx plus ndy. So for example, dy by dx plus f of x comma y is equal to 0. This equation 1. But sometimes conversely written as m dx plus ndy is equal to 0. This equation 2, where m and n are fractions. M and n are fractions of x and y are constants. Okay, so next, this is also ordinary differential equation. So next, equation in which variable are separable. Very important topic, variable or separable. What is the variable or separable? So differential equation, if the differential equation mdx plus ndy is equal to 0, mdx plus ndy is equal to 0. What is the mdx plus ndy is equal to 0? Ordinary differential equation is of the form, sometimes conversely written as of, so mdx plus ndy is equal to 0. So can be put in the born of so f1 of x dx plus f2 of y dy is equal to 0. So the condition replaced the equation f1 of x into dx plus f2 of y dy is equal to 0. So we said that the variable are separable and the solution obtained by integrating is mod f1 of x into dx plus f2 of y into dy is equal to 0. So this is also equation of separable, variable or separable. What is the variable? X and y condition is also a variable. Separable means x terms and x variables on this side and y variables on that side. So this is also variable or separable. So that next condition is also is of the form mod f1 of x dx plus f2 of y into dy is equal to 0. This is also. So today topic discussion about the tough topics. So differential equations, definition of the differential equation. What is the differential equations? So involving the differential equations which involving the independence variables or dependence variable, one or more independence variables or dependence variables involving this different equations is called a differential equation. So differential equations two types. So two types. First one is also ordinary differential equations and partial differential equation. So ordinary differential equation. So definition of ordinary differential. What is the ordinary differential equation? Is of the form conditions. So only one independent variables involving the only one independent variables is called a ordinary differential equations. And next, partially differential equation. Partially differential equations involving the two or more independent variables involving the these values is called a partially differential equations. So next, ordinary differential and partially differential equations definitions. So next, degree, order of conditions and degree of conditions. So differential equations lo ordinary differential equations lo two types of variable ni involving the conditions. So first, degree of conditions. How to find the degree of condition and order of conditions. That equations ni second order of conditions d square y by dx square whole power 3 conditions plus 2 into dy by dx is equal to 0. That equation, for example, so d square y by dx square 2 is also d square 2 is also order of 2 conditions. Whole power 3 is also. So degree of condition 3. So next, partially different ordinary differential equations ki condition ordinary differential equation is of the form, very important, ordinary differential equation dy by dx plus f of x comma y is equal to 0. Sometimes conversely written as mdx plus ndy is equal to 0. So this is also actually ordinary differential equation. But so these equations, so Veda, m and n are functions and x and y are constant. Okay, so variables are the functions, so constant. And next, very important, variable and separable. Variable and separable, which equations in which variables are separable? So variable means x and y, and separable means this side of x conditions is also totally value of this side of x conditions, that side of y conditions is a total value of y conditions. So this is of the form ordinary differential equation of the form mdx plus ndy is equal to 0, and then can be like to put in the form. So put in the form f1 of x dx plus f2 of y dy is equal to 0. So these conditions, for example, so solve the one example of problem. 1 minus x into dy plus 1 minus y into dx is equal to 0. Solution. So given solution equation is 1 minus x into dy plus 1 minus y into dx is equal to 0. This equation 1. This is also ordinary differential equation, is of the form mdx plus ndy is equal to 0. So comparing the ordinary differential equation, this equation. Okay. Next, dividing the equation by 1 minus x, 1 minus y. Dividing the equation 1 minus x into 1 minus y. And next, cancelling the 1 minus x by 1 minus x, and plus 1 minus y into by 1 minus y. So cancel these conditions. And next, so dy by 1 minus y plus dx by 1 minus x is equal to 0. This equation 2. The equation 2 is of the form of f1 of x dx plus f2 of y into dy is comparing the, so input of can be put in the form f1 of x dx plus f2 of y into dy is equal to 0. This equation is also a variable and separable of and condition. First of all is also ordinary differential equation is of the form, and second is also put is of the form. So replaced with the mdx plus ndy is equal to 0, replaced with the f1 of x into dx plus f2 of y into dy is equal to 0. So solving equation 2. So variable of separable conditions. So integration dy by 1 minus y plus integration dx by 1 minus x is equal to constant value is also say condition. So integration 1 by 1 minus y log of 1 minus y plus log of 1 minus x is equal to log of c. Right, say LHS is equal to totally log conditions, and automatically so RHS is also log conditions. So put the log conditions. So log of 1 minus x into 1 minus y, log conditions log of 1 minus y plus log of 1 minus x. This condition totally one terms log. So written log of 1 minus x into log 1 minus y, 1 minus x into 1 minus y is equal to log c. Next, both side is also log is cancelled. So remaining value is also 1 minus x into 1 minus y is equal to c. So this is a hence the So generally required solution is also 1 minus x into 1 minus y is equal to c. This condition is properly, so separation of variable of conditions. So next second example, second condition, first one is also ordinary differential equation is of the given of one problem solved given of equation. So comparing the ordinary differential equation is of the form m dx plus n dy is equal to 0, but can be put the form of f1 of x dx plus f2 of dy is equal to 0. Next, dividing the equations, cancel the conditions, and next separation of variable. Next integration, both side integration, and right side is also totally log conditions, but left side is also condition is also totally log conditions, and right side is also log mentioned. So put the log conditions, and log of something condition plus log of something condition. This condition is also one terms is also log of 1 minus x into 1 minus y is equal to log c, and log of 1 minus x into 1 minus y is equal to log of c. Log cancel the log condition, and remaining value 1 minus x into 1 minus y is equal to c. This is also generally required solution. Next, second condition. Second condition is also solve e power y plus 1 into cos x into dx plus e power y into sin x dy is equal to 0. This equation, okay, e power y plus 1 into cos x into dx plus e power y into sin x dy is equal to 0. So next, solution. So given equation is e power y plus 1 into cos x into dx plus e power y into sin x dy is equal to 0. E power y plus 1 sin x is also so common of e power y plus 1 into sin x into cos x by sin x into dx plus e power y minus 1 by e power y plus 1 into dy is equal to 0. Cos x by sin x into dx plus e power y by e power y plus 1 into dy is equal to 0. This equation 2. Equation 2 is in the form f1 of x into dx plus f2 of y into dy is equal to 0. Solving equation 2. Integration. Separation of variable of condition. Integration. Cos x by sin x into dx plus integration e power y plus 1 by e power y plus 1 into dy is equal to c. So log of sin x, integration cos x by sin x is also a integration. So immediately, so log of sin x, this formula, plus log of e power y plus 1 is equal to c. This condition, so formula f dash of x by f of x is equal to log of mod f of x. Yes, f dash of x by f of x is equal to log of mod f of x. So log of sin x of into e power y plus 1 is equal to log of c. LHS is equal to both side log conditions, and remaining RHS condition is also a log condition of C. Log cancel, and next remaining value sin x of e power y plus 1 is equal to C. So e power y plus 1 into sin x is equal to C condition. This is also hence the required solution. First of all, one example of problem. E power y plus 1 into cos x into dx plus, again repetition, e power y plus 1 into cos x dx plus e power y sin x into dy is equal to 0. So e power y plus 1 sin x common. So given e power y plus 1 sin x, so common conditions, and remaining value cos x by sin x into dx plus e power y by e power y plus 1 into dy is equal to 0. So cos x by sin x, remaining value cos x by sin x into dx plus e power y by e power y plus 1 into dy is equal to 0. This is also 2 condition, equation 2. This equation 2 is of the form f1 of x into dx plus f2 of y into dy is equal to 0. Variable and separable condition of the formula, and solving the equation 2. Both side integration application, applied the integration, and next to solve the condition. Integration cos x by sin x into dx plus integration e power y by e power y plus 1 into dy is equal to c. Integration cos x by sin x, this is also formula log sin x plus log e power y plus 1. This is also formula. So given a formula f dash of x by f of x is equal to log of mod f of x. So apply the condition formula. Log e power y plus 1 is equal to c. Log c. Why? LHS is the condition is also totally log condition. So immediately RHS is also log condition. Apply the. So log of sin x into d power y plus 1 is equal to log of c. So both side log condition cancel, and remaining value sin x into e power y plus 1 is equal to c. So this is also e power y plus 1 into sin x is equal to 0. 0 means 0 or c. C is also constant. So this is also ends the required solution, generally solution. So this is also variable or separable is of the conditions, equations. So 2 equations is also example problems. So next third condition. Third condition is also solve the x into y square plus x into dx plus y into x square plus y into dy is equal to 0. This is also equation, third condition. This is apply the variable and separable. How to find the variable and separable? First of all is also a mdx plus ndy is equal to 0 is of the form. This is also ordinary differential, of course, but variable and separable, so given a condition, equation, mdx plus ndy is equal to 0 is of the form. So sometimes conversely written has these conditions. So it can be put conditions f1 of x into dx plus f2 y into dy is equal to 0, and third condition, so variable and separable. Fourth condition, apply the integration. Next, fifth condition, generally solution. So first of all is also this equation. So given equation is of the form mdx plus ndy is equal to 0. This equation 1. Equation 2. So equation 2 so can be written as, so f1 of x into dx plus f2 of y into dy is equal to 0. Next, third condition, separation of variable. Fourth condition, both side of apply the integration. Fifth condition, hence the solution. This is also 5 condition is also a variable and separable, very important topics, working rules. Most working rules, 5 conditions. So how to apply that equations. So first of all equations, and third example xy square plus x into dx plus yx square plus y into dy is equal to 0. So given solution, given equation is of the form mdx plus ndy is equal to 0, xy square plus x into dx plus yx square plus y into dy is equal to 0. X, so commonly value, so suppress the x value and this condition, and plus these conditions y is also separation of condition. So x of y square plus 1 into dx plus y into y of x square plus 1 into dy is equal to 0. So x square plus 1 into y square plus 1 common value, and remaining value x dx by 1 plus x square plus y dy by 1 plus y square is equal to 0. So common value x square plus 1 into y square plus 1 common, and remaining value x dx by 1 plus x square plus y dy by 1 plus y square is equal to 0. Next, x dx by 1 plus x square plus y dy by 1 plus y square is equal to 0. This is also condition. So equation 2 is of the form f1 of x into dx plus f2 of y into dy is equal to 0. Solving of equation 2. So second condition complete. First condition mdx plus ndy is equal to 0. First condition complete. Second condition f1 of x into dx plus f2 of y into dy is equal to 0 complete. And third condition is also integrations. Third condition means separation of variable. So of course already separation of variable x dx by 1 plus x square plus y dy by 1 plus y square is equal to 0. Next, fourth condition, both side integration, applying the integration both side. Integration x by 1 plus x square into dx plus integration y by 1 plus y square into dy is equal to c. Third equation, and multiply equation third ni by 2 y. So given formula. So integration 2x by 1 plus x square into dx plus integration 2y by 1 plus y square into dy is equal to 2c. So these conditions, log of 1 plus x square is of the formula. Formula means f dash of x by f of x is equal to log of mod f of x. So apply this formula. So plus log of 1 plus y square is equal to log of c. Right side LHS of condition is also a log condition. So automatically, so RHS condition is also log conditions. So log of 1 plus x square into 1 plus y square is equal to log of c. Both side cancelling the log value. And the remaining value 1 plus x square into 1 plus y square is equal to c. Or log 1 plus x square into 1 plus y square is equal to 2c. Of course, 2c, 2c, 3c, this is also constant, no problem. So this is separation of variable. Of course, variable are separable. So working rules, 5 conditions based cheskoni. So 5 condition apply this equation. So hence the required solution. First one is also mdx plus ndy is equal to 0. Is of the form, of course, ordinary differential equation. So apply the mdx plus ndy is equal to 0. This is the separation of variable of conditions. So first working rules, so first main is of the form mdx plus ndy is equal to 0. And the second, so can be written as f1 of x into dx plus f2 of y into dy is equal to 0. Third condition, separation of variable. Separation of variable conditions equation immediately. Fourth condition, applying the integration both side. Next, applying the both side, fourth condition complete and simplification. And fifth condition is also hence the required solution. This is also separation of variable of condition. So separation of variable of conditions, totally values. So 5 working rules. So totally 5 conditions working rules pay చేసుకొని so apply the equations totally values ni solve the total values. So separation of variable very important of topic, so very so important of topic and next solve the all questions. So thank you very much.